Zeina, the corporate communications specialist here at Sopogy, where we're creating simple solar technology solutions for commercial, industrial, and utility clients. In this episode of SopoHow, I'll explain how our micro CSP parabolic trough technology is used to create solar air conditioning. In solar air conditioning, a set of Sopogy micro CSP SopoNova troughs are connected to a thermally activated chiller running on heat. Different types of thermally activated chillers are absorption, adsorption, or desiccant systems. Adsorption and desiccant chillers are less common, so we'll focus on the absorption chiller principle. In these systems, water, the refrigerant, absorbs heat at a low temperature and low pressure during evaporation and releases heat at a high temperature and high pressure during condensation. Lithium bromide solution, which acts as the absorbent, is used to absorb the vaporized refrigerant. The evaporation of the refrigerant takes place at a low pressure. The diluted solution, which contains the absorbed refrigerant vapor, is heated at a higher pressure. As lithium bromide becomes dilute, it loses its capacity to absorb water vapor. It therefore needs to be reconcentrated using a heat source. This leads to the vaporization of the refrigerant, and thus the solution is restored to its original concentration. The cycle keeps repeating itself to give the desired chilling effect. Absorption chiller system efficiencies are often around 0.7 COP, or coefficient of performance, for a single effect, or 1.2 for a double effect absorption chiller, making for a good complement to the efficient Sopogy micro CSP solar collector. SopoNova is the ideal technology for solar air conditioning because of its unique sun tracker, which gives the system higher production and storage, allowing for consistent and reliable operation. As demonstrated in this graph, solar air conditioning is an ideal renewable energy solution as there is a direct correlation between solar radiation and cooling load demand. The red line signifies the available solar radiation on a typical summer day, the blue line signifies a typical building cooling load, and the green line signifies a typical cooling load harnessed from solar energy. When the sun is at peak radiation, the demand for air conditioning is at its highest. Likewise, this is when solar cooling is also at its highest, as it is using thermal energy to directly drive the solar AC system. This makes solar air conditioning an ideal solution for our customers. Remember, every customer's need is different, so please visit us at www.sopogy.com and contact a Sopogy Solutions Center near you to get a preliminary site evaluation. That's it for this episode, but check back soon for our next episode of SopoHow.